2.8, solving inequalities.
For what? 2.8?
In one variable. There's no notes.
I looked for them last night.
Determine the x values that cause the polynomial function to be 0, positive, and negative. So, starting with number 4, we have f of x equals 5x plus 3 times x squared plus 6 times x minus 1.
So why are there no notes for this section? Is it because...
Probably because it's short.
They're short. Like, literally, if you look through the book, it's just all examples.
I don't like this chapter.
I think chapter 3 is my favorite chapter.
Like, is it hard? Is it really, really hard, or is it just like, oh,
It's not bad.
I don't mind this chapter. I don't mind it at all.
You turn your
All right, so how would I find the zeros? That should be something that we already know how to do without me really having to go over anything.
Right.
You kinda don't you
So
set,
make
like
all them all
equal
to 0.
Yeah, set each piece equal to
So 5x plus 3 equals 0, x squared plus 6 equals 0, and x minus 1 equals 0. So x equals negative 3/5. This one is x squared equals negative 6, or x equals plus or minus the square root of negative 6. So because we can't actually have that happen, we're just going to cross that one out. It's gone. And x equals 1.
Oh, I love the ones that are just x equals 1.
Makes sense.
So now we know where our zeros are. Okay? So we're going to be, in a sense, making a little table. It's like a sign graph, in a sense. So we set this up. We put our zeros on here. So in number order. So negative 3/5 and then 1. And then ultimately I'm finding my zeros, which I've already given as x equals negative 3/5 and x equals 1. I'm going to be finding where it's positive and where it is negative. So notice these are, they're going to be intervals, okay, for the positive and negative part. So what I do, I'm going to, first of all, extend these up a little bit so it doesn't get confusing. It's not as bad with these ones, but when the ones that are like a function over a function, it gets to be a little bit more confusing. So I'm going to pick a number that is in this range, and I'm going to plug it in and see what sign it is. All I care about is if it's positive or negative. So something that's smaller than negative 3/5, negative 1, that's smaller. So I'm going to plug in negative 1, and all I care about is the sign positive or negative. Okay, so 5 times negative 1, that's negative 5, plus 3, that's still negative. So in a parentheses, I put a negative sign. Negative 1 squared becomes positive plus a positive, so it's positive. Then negative 1 minus 1, that's going to be negative. So we put a negative. So then this whole thing here is positive. Negative times positive is positive.
Oh, yeah. I don't know why that.
So then I need a number in this range. So I'm going to use 0. Okay, so 0 plus 3 is positive. This the middle one, 0 plus 6 is positive. Then the last one, 0 minus 1 is negative. So this whole thing is negative. Then the last one, I need something bigger than 1, so I'm going to go with 2. So the first one is going to be positive because there would be no negative signs in it. Second one is going to be positive because there's no negative signs. And the last one, 2 minus 1 is positive. So that whole region is positive. Now, a lot of the time,
Mrs. Quinn?
yes,
Hey, are you able to pick up real quick?
yeah. Hey. Okay, that's what I'm thinking. Yeah. Yeah. Can I call you back in a few minutes when I'm done teaching and we'll discuss it more? Okay, thank you. Bye. More often than not, you're gonna see them alternate, but that's not always the case. Okay, so don't assume like, oh, well, the first one was positive, so I can just figure out the next ones. But a lot of times you will see them alternating. It's just the nature of how it works because they typically are turning around, changing direction, which is why it does that. So our positive region, we would have from negative infinity all the way up to negative 3/5, not including. Union from 1 to infinity is the other positive region. Then my negative region is from negative 3/5 to 1. And they're not including because those are actually the zeros. Okay, so we just want where it's positive or where it's negative. All right, number 6. F of x equals x plus 2 cubed times 4x squared plus 1 times x minus 9 raised to the 4th. So for my zeros, obviously the powers on the outside of the parentheses are only telling you how many times basically that's a zero. It's the multiplicity value that we were doing in a couple sections ago. So I don't care about that. So I just need to set each of them equal to 0 to solve. And honestly, if you see this and you can do it in your head, you're more than welcome to just say x equals negative 2. This one I might actually need to work out because x squared equals negative 1/4. So you can go ahead and just say that one's going to be gone because there's going to be a negative in the radical, and x equals 9. So if you don't want to actually like show setting each of them equal to 0, that's completely fine. I usually don't because it's just more writing that I don't need to do. So put my zeros on, negative 2, 9. So I'm looking for the zeros, which I've already found is x equals negative 2, x equals 9, and then where it's positive and where it's negative. So plugging in a value, so if I go with negative 3 plus 2, that's negative. Cubing a negative stays negative. Negative 3 squared becomes positive. Everything else is positive, so that's positive. Then for the last one, it does not matter what the value is inside because anything raised to an even power is what? Positive. So this first region is negative. I'm going to use 0 in the middle region. Anywhere I can use 0, I'm going to use 0 because it's obviously easier to work with. So that means that's going to be positive. Putting in 0, that's positive. We said anything raised to the 4th power is positive, so we don't care about that. Or, like, we care about it, but it's just going to be positive. We don't have to look at it closely. So the whole region is positive. And then if you went with 10, everything's positive in the first one, so that's positive. Second one, everything's going to be positive. And the last one, everything's positive. So that whole region is positive. So this is one where they don't alternate, okay? It just means that there's a 0 and then it continues to go positive. So our positive region is from -2 to 9, union 9 to infinity. So that means everything except for 9. Okay, that's what that's saying, from -2 on. Then our negative region is -infinity to -2. All right, so the next ones are a little bit different. And it says to complete the factoring if necessary. So if something's not factored all the way, you'd have to factor it first. And then solve the polynomial using a sign chart, support graphically, which you don't have to do the support graphically part. So number 8, 2x plus 1 times x minus 2 times 3x minus 4 is less than or equal to 0. Now, what's different about this problem compared to the other ones? It's an inequality. It says less than or equal to 0. So what does that mean? What values am I looking for?
Negative.
Or
0.
0. So I only care about where it is negative or 0. In this case, okay? So with the inequalities, you've got to watch what's happening with it, because that tells you what values you want. With this one, since it's including 0, that would mean that we would have a bracket instead of a parentheses for the regions that are negative, because that would be including the zeros. Okay? If it was just less than, then it would still be parentheses instead of brackets, because we wouldn't want the zeros. So we find zeros the same way. So I have a 0 at x equals -1/2, at x equals 2, and at x equals positive 4/3. Fractions in these can be really annoying, especially when they don't have a whole number between them and the next number to check. So before -1/2, I would check -1. So that's going to be -2 plus 1, so that's negative. Negative minus negative is negative. And then negative minus a negative is negative. So that whole region is negative. Then in the next one, 0 is an option for me to check, so I'm going to use that. So plugging in 0, that's positive. Plugging in 0, that one's negative. Plugging in 0, that one's negative. So that whole region is positive. Now the next one is a little bit harder because it's,
There's no whole number.
there's no whole number. I would just say use 5/3 because you know it's bigger than 4/3, and for the one that's going to be weird, it's going to cancel out. So, because in this first one, plugging in 5/3, that one's going to be positive no matter what. Everything's positive. (5/3 minus 2, well, 2's here, so I know it's got to be negative because it can't be, so you don't have to think about it too hard. Now, plugging in 5/3 here, 3's cancel, so that leaves you with 5 minus 4, so that's positive. So that whole region is negative. And then something bigger than 2, just go 3. So 2 times 3, or well, that whole thing's going to be positive. All of it's positive to begin with. 3 minus 2, that's positive. 3 times 3 is 9 minus 4, so that's positive. So that whole region then is positive. So remember, I only care about negatives and 0. So my solution is from negative infinity, obviously we don't include infinity, negative infinity to negative 1/2, and it's including because we are okay with zeros. Union, the other negative region is 4/3 to 2, and it's including both of those. Alright, I'm going to let you guys try the next one on your own. It's 2x minus 7 times x squared minus 4x plus 4 is greater than 0. So, notice this one. It's not all the way factored, so you need to do that first. You need to factor it first, and then you need to pay attention to what values you need with it being a greater than. And just so you know, once you factored it, you can use the factored form when you're plugging the numbers in to check. You don't need to like go back to the original because
Oh, cool.
it should be equivalent, but it makes it a little bit easier to deal with. Have we gotten a solution yet? Okay, that's fine. Do we have a solution?
Yeah.
What do we get?
You can go.
I guess let's see. I got -2 to not including union 7/2 to positive infinity.
Does anybody agree with him? Disagree with him?
Is this the one that you only worry about the negatives?
This one's a greater than, so you only worry about the positives.
Positives. So I have bracket 7 halves to infinity.
Okay, does anybody agree with either of them?
I have not.
Disagree with them?
I think I was getting close to Nate.
I got something else.
I-
What'd you say, Nathan?
I think it was Nate.
He said bracket 7 halves to infinity.
Yeah.
So, what scenario do I use a bracket?
If it's greater than or equal to?
Yeah,
it's
that's
correct.
So it's just parentheses.
So it's just parentheses. So you had to factor the first part into x minus 2 squared, then find your zero. So those were 7 halves and 2. Be careful because those are not in numerical order as they sit in general. So make sure you pay attention to that because that will potentially throw your answer off. And then you just check values. So I checked 0, I checked 3, and I checked 4, I think, were the ones that I used to
I
plug
got
them
it.
in.
Partially correct.
So the second part, because it's being squared, no matter what happens, it's positive. So I only care about what's happening in the first part. So using 0, that would have made that negative. Using 3, that made that negative. And using 4, that made that positive. So that's why.
I see what I
I factored.
did.
So it's for the one that
I only plugged it into
I
one
said
of
it
the
was
x
x
minus 2s.
2x plus 2.
That would be why I got a different answer.
Instead of the squared value.
Yeah.
Otherwise, if I didn't factor wrong, it would have
Yeah,
been right.
that's a perfect square trinomial.
Yeah, I thought that, and then I went back and did more math, but it was wrong math, so.
All right, the next ones are fractions in terms of it's a function over a function, but it's like in factored form. Okay, so it's one of those all over. But now, because of that, we're looking for zeros. We're looking for where it's undefined, where it's positive, and where it's negative. So we're checking everything. The undefined values will still get treated like zeros in terms of being written on here, but we have to note that they're undefined, that it doesn't exist there. So they can't exist there. These are all equality ones, so, or at least this round of them is. So number 26, f of x equals 2x minus 7 times x plus 1 all over x plus 5, and that's equal to 0, I guess you could say, technically. Or, well, we're setting it equal to 0. So I guess if I'm going to do this, I should write it in a different color.
Yep.
So I'm going to be looking for zeros, undefined, positive, and negative. All right, so where would this be undefined?
On the bottom.
When the bottom equals 0, so what would that be equal to? Or when x equals what? It's undefined. So if x equals -5, it's undefined. Yeah, I knew what you meant. Where are my zeros?
X equals 7/2. X
X equals -1.
equals -1.
So then those values are getting put on, so I've got -5, -1, and 7/2. So now we're doing the same thing where each factor exists. We're going to do that, or we're going to plug in a value that's in the range. So it's now going to be a little fraction that ends up getting written with your signs. So let's do -6 over here. So we put in -6. That's going to be a negative minus a negative, so that's negative. -6 plus 1, well, that's still going to be negative. -6 plus 5 is still going to be negative. So I end up with a little fraction. Kind of ends up looking with little faces. So negative times negative is positive, divided by negative is negative. So this region is negative.
That's so cute.
That's like a face. Actually, it's kind of cute.
Looks like a frog.
Oh,
It
does
does.
look like a frog with a line
Very,
in
like,
its face.
confused.
Oh, wait,
So
that's
then-
not-
That's
yeah,
someone
I
else,
see it
Josh.
now.
You're right.
In here, -3, split the difference. So -3, so that's going to be a negative minus a negative is negative. -3 plus 1 is negative. -3 plus 5 is positive. So it's negative times negative over a positive.
It's so positive.
So this whole region is positive.
Delete this.
The next region's where I have 0, so that's going to be negative. Then positive over positive, so that region is negative. Then 4, I can check for the outside one. So 2 times 4 is 8 minus 7, so that's positive. 4 plus 1, that's positive. 4 plus 5 is positive, so that one is positive. So when you do this, I would make a note here that this is undefined, so that when you go to write your brackets, you don't accidentally include them if you had one that was like a less than or equal to or greater than or equal to or something like that. Obviously, this one's just an equality, so we're not including because those are zeros. But if it was an inequality one like you had up here, you would want to note where it's undefined. So it's positive from not including -5 to -1, union 7/2 to infinity. And it's negative from -infinity to -5, union -1 to 7/2. So these aren't really hard, they're just tedious, I guess. That's the right word for it.
Yeah. That is a great.
What?
They are very tedious.
Look them.
Hold on.
Josh, what? Why'd you say that? No, no one said that. Tedious? I said that would be a good word.
All right, so one like this, but that is an inequality because I feel like the equalities are pretty straightforward. The inequalities are the ones that you have to think about a little bit more. So number 36, x squared minus 4 over x squared plus 4 is greater than 0. So this is greater than, so I care about what values.
Positive.
Positive. All right, so is there anywhere where this is undefined?
No.
No. So there's nowhere that it's undefined, so I don't have to worry about that
Have to tell.
because you set the denominator equal to 0. So if I set this equal to 0, x squared equals -4, take the square root of -4. It's not real, so there's no value that can make it 0. So now I need to find my zeros of the top. I need to factor it for, well, I guess I don't really have to factor it first. You could factor it first, or you could just set it equal to 0. So it's a difference of squares, so it would make it easy, but you can also just do this. So just remember, when you take the square root, you've got to have the plus and minus, which is the only hesitation with not doing it as a factoring. So these are my zeros. So -2 and at 2. So I check the same way. So let's say -3, that being squared is 9 minus 4. So that's going to be positive, over value being squared, that's going to be positive. Middle one, if I use 0, then I'm left with a negative over a positive. I guess I should have said the first one is positive, the second one is negative. Then in the last one, if I use 3, that's going to be the same thing as if I did -3, so that's going to be positive over positive, which is positive. I care about my positive regions, okay, remember, it's not or equal to, so I don't include. So my positive region, which is the solution, is from -infinity to -2, union 2 to infinity.
So did we just use the top to find the zeros?
Yes, the bottom would be whatever's undefined. And obviously there are going to be cases where the bottom would have zeros.
And so that would be what was undefined?
Yeah, that's what I mean, like where it would
Yeah.
be equal to 0. That's,
Okay,
yeah,
yeah.
saying there would be zeros is not really the right.
Which will make it
It would be
undefined
equal to
at the
0,
bottom,
which makes it
right.
undefined, yeah.
Okay.
So always check it, but in this case there wasn't one. 38. We're gonna set this one up together, and then I'm gonna let y'all solve it after that, because it's gonna be two things that have to be factored. So x squared plus 3x minus 10 over, or all over, x squared minus 6x plus 9 is less than 0. So, first of all, what values do I care about?
Negative.
Negative. I only want negative. I need to factor first, so what would this top factor into?
Unknown.
X squared.
Like,
Factors of 10 that give you
X
3.
minus 5x plus 2.
No, x
That was
plus
late.
5, x minus 2.
X plus 5, x minus 2,
I really went on my guess. Sorry.
Right, you got it right just like
over. Now, the bottom is a perfect square trinomial.
So,
x
X
minus 3 and x
minus
3.
3 squared.
So it's less than 0. So now you need to find where it's 0 and where it's undefined. Okay, if those occur anywhere, and then do the sign chart. So I'm gonna have y'all pick it up there and do it now that we've set it up.
So it's undefined if you set it equal to 0.
If the denominator is 0. If the denominator equals 0. And the squared part we don't care about because the squared part would go away as soon as we set this whole piece equal to 0. So basically you're setting x minus 3 equal to 0, and that's where it's undefined. And you can use the factored form when you plug in the stuff for the sign chart. Y'all found an answer yet? What do we get?
For the zeros, x is negative 5 and x equals 2, and then x equals 3 is undefined.
Mm-hmm.
And then for the negatives, I don't know if this is right. I got negative infinity to negative 5 union negative 5 to 2.
Can you say that one more time? Sorry. I was trying to like
No,
register.
I got negative infinity and negative 5 and then union negative 5 to 2. I don't think that's right.
Okay. Does anybody agree with her? Disagree?
Different answer.
Okay, well what's your different answer?
I got negative 5 to 2.
Okay. Does anybody agree or disagree with either of them?
I got negative infinity to 2.
Oh wait, wouldn't it just be negative infinity? Hold on. Cause that would be less than 0, right? Oh. Oh, I didn't.
So the zeros are negative 5 and 2 and 3, so we can't, it's just less than 0, so we can't include negative 5. So, and we can't include we can't include positive 2
Oh, it's 'cause
either.
I did it. Oh my goodness.
It's okay. I sat here going crazy because I looked at the answer in the book and it was only -5 to 2, and I definitely had that it was also 2 to 3, and I could not figure out what was going on. I was plugging in 1.5 instead of 2.5. So I was like, what is going on? This is not right. And then, anyways, I plugged in 2.5 in this region. That's why I ended up writing them across the top because I was plugging in the wrong number every time.
Well, I just did mine wrong. So the second half of my answer is, yeah.
Surprisingly, I did.
So we plugged in I did -6 for the first part, so that makes the first one negative, second one negative. The bottom's always positive, so across the board the bottom will always be positive. Plugging in 0, you have a positive and a negative over a positive. Plugging in 2.5, not 1.5, like I did at least 5 times. You get a positive over a positive, and then plugging in 4, you have positive, and positive. So that's why it is -5 to 2, not including any of them. If it had been a less than or equal to, we would have been able to include both the -5 and the 2. If it had been the region, like, let's say if it had been the positive region, we would not have included 3, even if it was a greater than or equal to, because it's undefined. We can include zeros when it's greater than or equal to. We cannot include undefined values. All right, so there's your problems.
Oh, you not rewrote this, did you?
Oh, great.
I did. I actually took off one of the problems because I was like, yeah, I don't really feel like doing that one. And you would need your calculator to do it anyway, so it seemed a bit excessive.